The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Apache Spark, Process Big Data Smart. In our panel today, we have two guest speakers. Our first speaker is Mr. Raghavan Soliam. He is lead architect at Big Data at OSS Cube. Our second speaker is Mr. Anurag Dutt. He is also associated with OSS Cube, and today he will brief us about OSS Cube functioning. So without any further delay, I introduce you to our guest speaker. Over to you, Anurag.
Hi, thanks everybody for taking time out of your busy schedule for this webinar on Apache Spark. I will start with a small presentation on OSS Cube, and then I will give rights to Raghavan where he can go ahead with the webinar. Introducing OSS Cube. OSS Cube is a global solution provider. We deliver integrated mission critical solutions using open source. We work with customers across 16 countries to deliver robust, scalable, and high performance using open source technologies. As far as Hadoop is concerned, we have got a dedicated Hadoop practice. We have partnership with Cloudera, and for the organizations who want to start with the Hadoop, we also have a partnership with AWS. We are CMI level 3 certified organizations. We have locations across US, UK, and India. As far as OSS Cube is concerned, we don't only use open source solutions to come to solve customer issues, but we also actively contribute to the open source community. We organize open source conferences, we organize meetups, we organize conferences on databases and Hadoop in New Delhi and in other cities. OSS Cube has a broad set of competencies, but what is our greatest strength and really what separates us from other open source solution provider is our ability to integrate many applications into a solution that can help to meet customer business objective and differentiate customer from the competition. As you can see, we have the competition. We work across Talent, we work across Cloudera, we work across Magento, we work in Sugar CRM, we work in Zend. In fact, at all the spectrum you see, we are the Zend only World Center of Excellence. Sugar CRM, we are the platinum partner. Cloudera, we were the first trading partner in the Asia Pacific. Talent, we are the only partner in the Asia Pacific as far as the license resale is concerned. So that's what giving you the sort of horizon in terms of what does the meaning of integrated business solutions mean. As far as Hadoop is concerned, we offer basically Hadoop consulting, Hadoop implementation, Hadoop support, and Cloudera training for Apache Hadoop, which we have been doing for last 2.5 and 3 years. In fact, we were the first authorized Cloudera training partners in India, and we started doing trainings in India. And we facilitate enterprise to deploy Hadoop with a proven way and build big data applications with transformation potential. Our Hadoop services are tailored to meet the needs of the startups to large organizations while allowing scalability as the business needs expand. Why OSS Cube? Because we have Cloudera certified developers for Apache Hadoop. The industry's only recognized certification for software developers. We have enterprise architects and consultants with more than a decade of experience. We have experienced trainers and consultants who have delivered training to the global leaders. And we have got in-depth expertise over the material necessary to configure and use Hadoop in the enterprise. Starting with the webinar, just to give you a small introduction of the speaker today, Raghavan has got over 17 years of experience in the IT industries and has delivered critical and strategic IT solutions to clients in multiple industries. Data has been his major interest. He has a very strong background in the databases, data modeling and data warehousing. In last few years, he has added big data as his forte. He is a Cloudera certified trainer for developer administrator classes and has conducted several trainings and consulting assignments. In the Hadoop stack, his experience covers Hive, Pig, Flume, scoop administration in HBase, and is also familiar with NoSQL technologies such as MongoDB. I will not take much of your time. Now I will pass it on to Raghavan for the webinar session. Raghavan, it's over to you.
Thanks, Anurag. So I'll just share my screen. Yeah. So hope all of you are able to see my screen. So welcome to this webinar on Spark and how we process the big data smart using the Spark. So it's very exciting to present this webinar to all of you. We have close to 140 participants on a Monday afternoon, so which is a great gives a great feeling about the interest of the community about the Spark and big data happenings. So last time, if any of you attended the webinar, we had a discussion on the MapReduce and what are the suitable use cases for MapReduce and what does not work for the MapReduce. And also we discussed the internal workings of the MapReduce as well in the last webinar. So this time we wanted to have a discussion and presentation on Spark because we felt that it is the move in the right direction. So considering the developments that are happening in the big data area, specifically the Hadoop. So first of all, why we want to have a different tool and a discussion on that. So before moving on to the main topics, the expected audience, as usual, it can be architects, tech leads, developers, and QA professionals typically from the analytics and the data warehousing practices. For this webinar, peer knowledge of Hadoop is not necessary, but if you have some idea about the big data, it will be really helpful because there are some assumptions made in these slides. That you have a little bit understanding about the big data and a little bit of the Hadoop working. So without any delay, let's move on to our the slides. So today in the webinar, we'll discuss what is the need of the Spark in the first place, and what is Spark and what features Spark provides, and what is its place in today's data processing world. And the use cases typically which are suitable for the Spark. Towards the end, we will dedicate 10 to 15 minutes for the question and answers. So moving on, so this is how I feel today if I look at the big data world. There are so many products, so many things, and so many claimants saying that this tool is better than other tool. This tool is not suitable for this kind of processing, and there are tools which are overlapping as well in terms of their functionality and the abilities that they provide. So it's a very confusing today. If anybody who wants to enter into the big data area, he will end up hearing around 100 or 200 products and tools. And in fact, if I try to put all those tools on this slide, probably I cannot, I probably will need all the slides of the presentation to fill those tools. So just as an example, I put some tools here. But if you try to see what these tools do, they typically do two kinds of processing, data processing. So one is a batch oriented, which are typically MapReduce based, and then there are other set of the tools which are special purpose, who does iterative kind of processing, interactive processing, streaming processing. So I just want to differentiate between the first group that I'm talking about and the second group. Here you process data in a batch oriented mode. You submit your job and you might expect your result maybe in an hour's time or half an hour's time or however long you are willing to wait. But whereas the iterative or the interactive processing is where you would expect the result back in a short time. It could be, it depends on again your use case. It could be a minute, or it could be few seconds, or it could be on a scale of 5 minutes, 6 minutes, like that, but not beyond that. So these are the two different kind of tools that we can categorize the today's big data tools. And then one of the key thing about these tools is that most of them are built around Hadoop. So though I have put the Hadoop as a separate tool, but Hadoop as such is a combination of a file system called as HDFS and a processing engine called as the MapReduce engine. And the tools and products that we're seeing here, most of them are built around them. Either they will use both those core components, or they will use the HDFS, which is the file-based system. So we already have so many tools, is what I'm saying. And why do we need another tool? So to understand this, we have to get a little bit more deeper into the Hadoop's world and its evolution and what it can offer and what it cannot offer. So based on that, we'll have a natural progression into the Spark discussion. So let us see what is the need of the Spark. So before that, it's not a wonder or surprise if I say that every one in this web conference would have heard or would have worked on the Hadoop. It's no exaggeration. So Hadoop has dominated the big data space for so many years for now. Almost, I think, it existed for 11 years. It's 11 years, and it's recently coming to the limelight. Started coming to the limelight. And then it is an open source tool that we all know. And then the total cost of ownership is very less for Hadoop because it can work on commodity machines. It's highly scalable because it works on the master-slave mode. You add more slaves to your cluster. It scales as per your performance and capacity needs. And it is also elastic. As and when you need, you can add capacity. When you don't need, you can get rid of those additional worker machines. And then it has a lot of ecosystem tools, like I mentioned, which one way they are helpful, another way it is a little bit confusing as well. So when we have so much of support around the Hadoop ecosystem, so why do we need a different kind of the tool or the product? So there are some downsides to the Hadoop as the industry has experienced in the past few years. So it's very ironical to state that it is pretty slow as per today's standards, because the birth of Hadoop itself is based on the need for performance and speed. Our databases could not scale, data warehouses could not scale to the data volumes that we are handling today. So that's the reason Hadoop has been built. At that time, everybody said, yes, this is what we were looking for, this is the speed. But later on, the data volumes have increased, and the kind of processing that enterprises wanted to do has increased dramatically. So as per the today's standards, it's pretty slow, right? It takes a lot of time. It cannot process certain kind of workloads like real-time workloads, streaming workloads. It cannot handle appropriately, right? And also the API is very complex. So the Hadoop API is very complex. It's written in Java. And then, of course, you have the tools such as Hive and Pig, using which you can write custom scripts, high-level scripts, and then execute. But it's again a reflection of the rudimentary nature of the Java API. But also, you cannot achieve an analytical task in a single job. You need to write multiple jobs where you will stream the data, and then you will clean it up, and then you might want to transform the data and then run some analytics on that, or machine learning algorithms on that, and then you'll be able to visualize or send it to another system where you would like to present it on a customer interfacing system. So it needs a chain of jobs. It cannot be achieved in a single job. So which is also a problem with the Hadoop. So these are few of the downsides, and if you browse on the internet, you might find a lot of other things, comparison with Hadoop and various other tools that are upcoming today. So first of all, what is the Spark, right? So it is an open source project. Actually, this was started by UC Berkeley around 2009 as a research project. So the main objectives while building Spark are to support the workloads that Hadoop could not support well. So, namely, it is iterative, running iterative algorithms, and then interactive data processing. These are the two things that were kept in mind while building the Spark tool. So it's also a low latency cluster computing framework. So keep in mind that this is also a cluster computing framework like Hadoop or other tools that you must have heard of. So this is a cluster computing framework. So typically it has a master Spark application master, which actually monitors all the slave processes, and the slave processes where you have Spark worker process running, which actually takes a part of the job, which is a task, and then processes, and then master takes care of overall aggregation and presenting it back to the user or storing it into a file system. So it is a cluster computing framework like Hadoop. So the architecture and the internal implementations are a lot different from Hadoop, so that you have to keep in mind. So it's also several times faster. So how does it get its speed? So there are a couple of things that makes it faster. So we'll see those things in the coming slides. And also, as it is built for iterative and interactive data mining, it excels at these kind of jobs much better than the Hadoop. And also, it can work on different kind of storage systems. It can work on HDFS. It can work on Amazon S3 data system, and then it can also connect to Cassandra kind of data stores to get the data and get it processed on the Spark environment. So Spark as such, initially it was built as a standalone application. It does not need any kind of environment to orchestrate or to monitor it. But later on it was migrated to the Hadoop Yarn, which is the generic resource management system of the Hadoop. So today it can run on Yarn, Hadoop Yarn, and then it can also run on Mesos, which is another distributed distributed cluster management system, which is the Mesos. So it can run on 3 different modes based on where you want to go. So this is briefly about the Spark. So how is Spark different from the Hadoop or any other systems, any other tools that are there as part of the Hadoop system? So one important thing is that it is a general purpose and easy to use API is built for Spark. So when I say general purpose, easy to use, if you have seen the Hadoop MapReduce, you have to write the programs only in mappers and reducers. Right? You have to typecast your code, your logic into either map or reduce, and then you have to write some Java code, and it is pretty complex as well. But whereas in Spark, you do not need to typecast your programs as mapper program or reducer program. You write the program very naturally. If I have to compare a little bit similarity of the way in which you write Spark programs, I can compare a little bit like a pig, but not exactly like that. So I'll show some sample code of Spark in the Scala specifically on the upcoming slides. And also it is not only it does the in-memory processing, but it is also taking care of the optimization of on-disk processing as well. So even if you don't store anything in memory and run a similar program on Spark, it would be much faster than you run it on the Hadoop MapReduce. So it is optimized for on-disk processing, and then it can also process your data sets in memory. So one of the downside of the Hadoop is that it writes everything to the disk. the data that is generated in between map and reduce, and the data that is generated by intermediate jobs as well. Like I explained in the previous slide, that you have to write a chain of jobs for achieving your analytical objective, and the data that comes out of each of the job is written to the disk. Right? It's a very, very expensive process, writing to the disk and then reading it back from the disk. But the Spark unified environment can have this intermediate result stored in the memory, and then the further task, further processing can access directly from the memory, which makes it much, much efficient than a normal Hadoop MapReduce way of the processing. So it does processing in memory, and also it supports different workloads. It can process a batch kind of workloads. It can process interactive real-time kind of workloads as well, which includes the streaming data as well, which we typically face in the Twitter or Facebook kind of data sources. And then it supports the functional programming paradigm. So functional programming paradigm is different from the object-oriented programming that we have been seeing in Java and in other languages. It is more expressive. It expresses how the data needs to be processed in terms of data, in terms of the transformations, rather than what needs to be done, like we see in our other programming languages. So it uses the functional programming paradigm, which is very good for data analysis and data processing jobs. And it also supports, the API supports writing the programs in Scala, and then writing programs in Python, and then Java as well. So these are the three languages that are supported just out of the box for the Scala. So you can write your programs in any of the languages. But the examples what I will show you on the upcoming slides will be in Scala, and the way of writing and the processing is more or less same in other languages as well. So it also comes with a rich set of libraries just out of the box. You have a module for processing your SQL queries, and a streaming module for processing your data streams, and then mlib for processing the machine for doing machine learning kind of the processing, GraphX for processing the graph-oriented data. So these are all out of box. You can immediately start using this and then be able to the process. And one of the interesting things here is that you will be able to combine these processes within a program. You can write a SQL, and you can do a machine learning process, a graph computation and streaming. You'll be able to combine this into a single program as different steps, which means that the output of each of these steps can be shared or can be processed by the next step directly from the memory. So this is it is unified data processing, which supports the multiple working workloads as well. So let us look at an example of a Spark program before moving further. So here is an example of the processing the data. So you have a log with error messages, and then you want to filter the log where it contains the error. So you have the data in HDFS, and then you can simply using Scala, you can load the data set using this val file, spark.txt file. You give the path, it loads this into the memory, and then you can filter using file.filter, and then line contains error. So this will filter the earlier data set by this condition. And then you can just simply say error.count. It will produce the count of the records that have errors. So it's as simple as that. If you have to write the same thing in Hadoop MapReduce, then you have to write a mapper, a reducer, you have to write a driver. It at least goes to at least 150 lines of the code. And the word count. Word count, again, if you want to do word count on a data file, you just load the file and then you just use the data transformations. Right? The file data here has been transformed using a function called as flat map. And then further you can map the words, and then you can call reduce by key, which actually will give you the word count. The same program in the Hadoop will take around 200 lines of the code. And like I said, you can also run a lot of the machine learning algorithms on the Spark directly out of the box. And in fact, Mahout, which is the famous the machine learning library on Hadoop, is also in the process of porting to the Spark. So we will be getting the support for Mahout on Spark very soon. So here is an example of a logistic regression algorithm which is used in classification. Typically you use this algorithm for classifying news, or classifying an email as a spam mail, or classifying say a tumor as cancerous and non-cancerous. So this is used for the classification. So you have a data file here, you just load it, and then you can do vector oriented processing, vector oriented and matrix oriented processing here using the Spark libraries, and you can iterate and you can calculate the classification function here. Right? So it's as simple as that. If for the same thing, if you have to do it in Hadoop, MapReduce, or even Pig or Hive, it takes a lot of lines. And also iterative processing is something you can see a for loop here. For loop, and you're storing some value and then trying to calculate some values which can later become the parameters for your classification equation. So these kind of things are almost impossible to do in Hadoop. You have to force fit into map and reduce, and you may have to go in several jobs. So it makes it non-performant as well as difficult to maintain and develop. So these are some examples of what you can achieve in Scala. So having seen the examples, now let us look into some core architectural details of the Hadoop. So not Hadoop, sorry, Spark. So the Spark has something called as RDDs. It is resilient distributed data sets. So these are distributed collection of objects of the data in memory. Right? These are all in-memory data sets. So it can be processed or accessed by your further steps very easily. And then you build them via transformations. Like we have seen in the previous examples, you load a file and it becomes an RDD. The file is an RDD. And then you transform that by filtering by a text called as error. And you are transforming that into a different RDD called as error RDD or something like that. So you transform and then you create RDDs in a sequence, and towards the end you would get your analytical output that you were expecting. Right, and it's also fault tolerant because in the previous examples that we have seen, in one of the example, one RDD is being converted to multiple RDDs in the process of getting our end result. So if anything fails in between, Spark is built to recreate that. So it is fault tolerant. Even if something fails, it can go back and it can recreate the RDD that has failed or that is missing. So it is also fault built for fault tolerance as well. So like I said, it can do different kind of processing just out of the box. SQL is one thing, graph processing is another one, machine learning is other one, and then streaming processing as well. So it has a different set of RDDs which can handle this kind of data sets and then take them through the RDD transformations as you go through your processing steps. So these are the different kind of the processings that you have. So what is the use of having a unified environment that you can do all these kind of different kind of workloads in a single job or together, is that you don't need to copy data between different systems. If you see in Apache Hadoop, you have to copy the data. You have to always write the data to HDFS, which is a disk write. Right? And from there, the further jobs will be able to access the data and the process. Right? So you don't have that kind of overhead here. And then other thing is that the steps, the different kind of steps, they'll be able to access the data directly from the memory and the process, which is much faster than writing and reading from the disk. Right? And you can combine all these kind of steps within a single the program. You can do an ETL process, you can do a machine learning process, and then you'll be able to do a SQL query on top of it. So everything you can do in a single job. And most of all is that you can reuse this code. Right? It is a single language, like you have you have chosen to write your programs in Scala or Python, one of these languages, right? So the reusability increases for your programs. On top of all this, the good thing is that you have one system to learn and maintain. If you look at the typical Hadoop kind of workloads, you will have a scoop job, you'll have a MapReduce job, you can have a peak or hive jobs, different kind of things, different languages, different teams developing it. Right? So here you do not have that issue. You learn one system, which is Spark, develop your programs in one language, either Scala or Python, and then you are good to go. You can write entire data processing in a single job. So this is the kind of the benefits that the unified processing environment that Spark brings in for us. Right? And looking at the use cases, so what kind of use cases are suitable for this environment, Spark. So we already talked a little bit about it, that interactive exploratory analytics. So I would like to give one example here. So for example, say that your enterprise wants to process some data that is streaming, that's coming from a streaming source like Twitter. So if you want to process this data in Hadoop, you would use Apache Storm or Flume to get the data, and then you want to query it using a interactive query engine like Impala or Dremel or something like that. So for this, you have to write the data onto HDFS first, and then only the tools like Impala will be able to query this data. So here itself, you are losing a lot of time there. So so that's one of the reasons why these query engines may not be able to respond as fast as you would expect. So whereas if you see in Spark, in Spark you can use streaming RDDs. Streaming RDD can create RDDs, in-memory RDDs through the streaming data. It can do a time division of the incoming data and convert this into RDDs in memory, and then you'll be able to, the tools like the SQL on the Spark will be able to query these RDDs and give you the data back in a matter of a few seconds. So this is the kind of interactive analytics that you can do on Spark. So interactive exploratory analytics is one of the use case. And the machine learning, we have seen the logistic regression example, a small example, which we could do in 4 or 5 lines of code. So you can do machine learning algorithms very easily because it supports vectors and matrix operations, and then iterative processing, which is not supported in the Apache Hadoop. So all these kind of things you can do. So machine learning becomes much easier on the Spark. And also you can generate real-time dashboards, about how things are progressing, or how your sales are moving at a particular particular shop. You will be able to produce the real-time dashboards. And also you can also do faster ETLs. You want to transform your data and then keep it ready for further analysis, or you want to load it into your high cost data stores, so you'll be able to do that quickly without much delay using the Spark. So these are a few of the use cases, but you can do much more using Spark. So whatever you can do probably on the Hadoop, plus the interactive and then iterative the processing, as well as you can do in the Spark. So these are the use cases, some of the use cases that you can do on the Spark. So it does not mean that MapReduce is going to disappear immediately. So MapReduce is taking its own codes and improvements in terms of it's shifting its focus. Hadoop itself, if you see, it's shifting its focus from being a processing engine to a management engine. So it's focusing more on the file system, which is HDFS, and then it's focusing more on the management engine, which is Yarn. So Yarn slowly is shutting off its job management, job monitoring responsibilities. So thereby the applications can take over the job management responsibilities, like Spark. Spark has its own application manager, which manages its own processes, and then MapReduce has its own the processing as well. So going forward, the focus of the Hadoop will shift from building applications to the managing the environment and the cluster. So this is briefly about the Spark, how it is, what is the need of the Spark, and how it fills the blanks or the things that Apache Hadoop cannot fulfill. So this actually brings us to end of the Apache Spark presentation. So we are left with another 20 minutes. So now we can take up questions if you have any. And for those of you who are interested in learning more on Spark, we have a Apache Spark training in December between 8 to 12 in Bangalore. So if you are interested, you can get in touch with Anurag. I have his contact details on the last slide. So you can note down and you can get in touch with Anurag for any further details. So Gaurav, back to you.
Yeah, thanks Raghavan for such a insightful presentation on big data, and we can add a Spark. Right, so let us quickly move to the question and answer round. I request you to please read out question first before answering them, so that all our users can get the commendable insight. So I request you to please go to the question tab. There you can get all the questions which are shared by our users.
Yeah, I just got. Okay, so there's a question. Hope everyone can hear me. There's a question on the Hadoop. Can I set up a single node Hadoop on my personal computer with 3 GB RAM? Yeah, though it's a unrelated question, the answer is yes. You can set up a single node cluster, a Hadoop cluster on your 3 GB machine. So the second question, I am a beginner to Hadoop. Do you suggest me to start with Apache Hadoop or Spark? Yeah, if you're a beginner, I suggest that you read about the Hadoop first. See, that is where the big data journey started. The reason for the birth of the Hadoop, and then how the core components work, like HDFS, what the purpose of HDFS, and what's the purpose of the MapReduce, and then you'll be able to understand the issues and appreciate the Spark. So I suggest that you understand the Hadoop core first, and then you can move on to the Spark. Right? You don't need to learn the API or the program, the Hadoop MapReduce, but it's necessary that you understand. If you understand these concepts, you'll be able to do well, anywhere else in the big data world. So comparing to Storm and Spark, which is good for building real-time systems. See, Storm cannot work on its own. Like I've given one example that you have to get the data and then you have to store it on the HDFS if you want to interactively query using Impala kind of the tools. So there you are creating a lot of delay. If you're dealing with a lot of data, it will take some time for writing that to disk and reading that from the disk. So obviously you'll be losing a lot of time there. Whereas the Spark can directly deal with the streams. The Spark can create the in-memory RDDs using the streaming data, and then that data can be queried immediately using Spark SQL. So, the answer is Apache Spark is a better option today than Storm. So, yeah, so is pig script supported in Spark just like Hive queries? No, pig scripts are not supported at this point on Spark. Yes, Hive queries is like, say Hive is a SQL interface. So now you have a Spark SQL, which is like a Hive on the Spark. So the answer to put the answer in a better shape, I would say that SQL is supported on Spark, which is like Hive queries. It can reuse the Hive metadata in case you have an existing Hive metadata. So the answer is Hive queries can work on Spark, but whereas pig scripts are not supported on Spark. Okay, so the next question is, okay, so one question I think I would like to take this question as well. Could you explain once again why Spark is faster than the Hadoop? So the reason is Spark can process the data in memory. It can store, it can process different kind of workloads together. For example, you have a streaming data coming, and then you want to process it, you want to run some analytics, you want to do some cleanup, and then you want to query using a SQL. So all these steps can be combined in a single job, and then the data between these jobs can be passed on using RDDs, that is stored in memory. Right? But whereas if you take the same case in a Hadoop job, what happens is each job has to write that to the HDFS, and the other next job has to read from the HDFS, which makes it very, very slow due to the disk read and write operations. And we are dealing with a big data, not with a small amount of the data. Right. So that is why it is faster. And then thanks for a very good introduction to Spark. My question is, does that mean with Spark I don't need to install Flume, Scoop, and Hive? Yeah, Scoop has a different role, right? Scoop is not a processing language. Sorry, it's not a processing tool. Even a Flume. So these are for getting the data, right? You are getting the data from RDBMS. You are getting the data from the Flume. Right, they are not handling streaming data, for example, Flume, and the Scoop is not handling and processing the data that is from database. So these tools still are required for Spark in order to get the data onto the HDFS. Whereas Hive is a language interpreter. So you write SQL, and then the SQL finally has to be converted to a Scala program behind the screens. So Hive is still required. These three are still required. So hope that answers your question. Okay, so for someone is asking about could you show some benchmarking that compare the performance with Hadoop? Yeah, you have a lot of stuff the benchmark stuff. In fact, Spark stood in the top position in the sorting competition. So there's a kind of sort comparison that goes on within the big data tools. In the recent competition, the Spark has stood on the top. So if I have to compare, the experiences say that it is 10 to 100 times faster than the Hadoop, the MapReduce. So yeah, so another question is about the fault tolerance in memory. Yeah, if it fails, it has the base data, right? It has the base data. From the data, it can reconstruct its RDD if it if it fails or if it crashes in between. It will be able to recreate the RDD back into the memory. So other questions. So what is the typical infrastructure for running a Spark cluster? Any specific on RAM requirements? Yes, you need a lot of RAM for running a Spark cluster because it does a lot of in-memory processing, though it is optimized for on-disk processing as well, but the power and the speed you get by storing RDDs into the memory. So you need a lot of memory. Typically, the requirement is you need machines, worker machines around 64 GB RAM, and upwards. So these are the kind of machines that you have that you need to have, and then octa-core processors are recommended so that you can multitask. You can run multiple tasks on a given the machine. Okay, is there any online training provided for professionals? No, at this point we don't have the online trainings. We do only the classroom trainings at this point. As I said, we have a classroom training scheduled from December 8 to 12 in Bangalore. So you can, for more details, you can get in touch with Anurag. So what is the best language for writing a Spark API? So Spark provides Java, Python, and Scala, and it supports the functional programming. And the naturally suited languages are the Scala and Python. Of course, it supports Java as well, but you should understand the functional programming paradigm well to write programs in Java. So it supports all these languages, and it depends on your preference what language you want to go. There is nothing like this is the best language because it supports internally all these languages, and it does not give any priorities or performance improvements if you write in a specific language. All of them behave the same. But it is built on Scala. So the code is built on Scala. So it depends on your preference. You are comfortable with Scala, you can go with Scala, or you are comfortable with Python and Java, you can go with them as well. So there is nothing like Spark recommends that this language is better for Spark. So how Spark behaves on node failure? It is very similar to the Hadoop, the way Hadoop job tracker or Yarn resource manager manages its nodes. The same way Spark also will do. It will try to reassign the task on a different node, and it will recreate the RDD which is required for that particular task. So okay, so what is the implication on having everything in the memory? Yeah, so it will actually increase the performance rather than it impacting your the process, right? So you have to ensure that you have enough memory for caching the RDDs. So if you do not have, yes, it might result in a page swapping right into the disk, and then resultantly it will result in impaired performance. So you have to, if you have enough memory, it will be faster. It will be much faster than how Hadoop would process the same data. So will Spark compete with SAP HANA, and how much market share it can capture with respect to in-memory and the market, the project? So these two, in my view, these two are two different domains. The enterprises who have their data on SAP, and then they want to process the data within their SAP systems, they might prefer the HANA, or only for the SAP related data they might prefer HANA. But Spark comes from a totally different domain. It is an open source the product, and then it can process huge amounts of data, which probably SAP HANA cannot handle. Basically, to store the data itself, it needs a lot of space, and to load the data into the HANA system itself, it might need a lot of memory there. So I don't know much about HANA to comment further on that. So what I can say is these two come from two different domains, and then the needs and the uses may be specific. Like I said, my SAP data I'll have processed with HANA, but my rest of the data, unstructured data, and then my other data that my enterprise data, I want to process using the Spark. So I believe that these two have a specific place and role in an enterprise. So what would happen when the data which is getting processed exceeds RAM allocated for Spark process? So it would swap the page. It will start writing overflowing to the disk like Hadoop does. So which means that your performance will get impacted. So you have to have enough RAM. So you have to equip your nodes with enough RAM so that the page swap does not happen. So you have to do a capacity planning for building a Spark cluster. Okay, do I need any tools from Hadoop ecosystem when the Spark already takes care of such functions? Yeah, you may not need the tools for processing. For example, if you are talking about machine learning, you'll be able to use mlib, Spark mlib. For graph processing, you can use GraphX. You'll be able to use, but still you will need the tools like Storm or Flume for getting the streaming data, and then Scoop for getting your data from RDBMS. So these kind of tools are still required. But the processing wise, it is the fully content. Most of the processing you'll be able to do using the out-of-the-box libraries that comes with the Spark. So any training being scheduled for Delhi or Noida? Not right now. We might have some plans. I think Anurag will be able to answer that the better. But immediate training we have in December in Bangalore. Manual fault tolerance is required for the Spark. It's not required. Typically in the Hadoop environments, including the Spark, you will not have the manual fault tolerance. Fault tolerance is automatically taken care by these master nodes. But if a master node itself fails, then you will be out of action. So typically the master nodes are configured in high availability mode so that even if one master goes down, the other master can take over for uninterrupted function of your cluster. So the next question is, do you recommend Spark on Play framework? So I don't understand this question, Play framework. So I'm not familiar, either not familiar or the question probably is not complete. Okay, so that is the end of the questions. I don't know if I missed enough of the questions. So I think we are exactly at the end of the session. So Gaurav, back to you. I think I've looked at all the questions.
Yeah, thanks Raghavan for taking so many questions. I really you took a lot of questions, right? So still we are getting a question from our participants. I request all our participants, if they have any question, they can visit our website techgeek.com and they can post their question on the Raghavan's big data page, right? So I also request Raghavan, please spare some time after a few days to answer all those questions.
Definitely. So I'll take some time, maybe in the next couple of days, and I will go through the unanswered questions, and I will post the answers for all of them.
Thank you. So I'm really thankful to Raghavan for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Thank you Raghavan. Thank you Anurag.
Thanks everyone.
Thanks everyone. Thanks.